Hi everyone, this is practice placement into Math 14, 31, 16 through 20. This first problem is kind of easy, but the rest of them are a little more complicated. So this is going to be a longer video. So basically they want to know what x is, and I drew the triangle. They gave me the triangle, and then I filled in what AB was 10 and BC was 13. So they want to know x. And so for x, we have adjacent and we have hypotenuse. So that's cosine. So cosine of x equals adjacent over hypotenuse. And then remember, you just take cosine inverse of inverse cosine of both sides. So you get x equals cosine inverse or inverse cosine of 10 over 13. Now, the way they write it on their test is arc cosines, means the same thing. Yeah, it's 2 c's, and that would be 10 over 13. So that's pretty much the easy one. The other ones aren't hard, it's just they take a few more steps. So the next one is we have to put this equation in standard form for an ellipse. Now, this is basically completing the square. So what I'm going to do is group my, you should know what the standard form of an equation of an ellipse is. I'm going to group my x's and y's together. It's pretty much set up for me. I'm going to do greatest common factor and pull out a 64, put an x squared minus 2x, and you might put a line. I tend to put a little box here. Okay, plus factor out 100 here, and I'm going to get y squared plus 2y plus box, and this is going to equal, it's really hard, 6,236, and then we have to add 64 times whatever we do to complete the square, plus 100 times whatever we put in the square. So basically, to complete the square, and again, you should already know these. I do have videos on explaining this more, but you take half of your b part, half of 2 is 1, square it, and you get 1. Same thing here. So basically, we're putting just 1 here. And then we're going to, this is a perfect square trinomial, so we're going to write it as x minus, take half of 2, and that's 1 squared, plus 100 times y plus half of 2 is 1 squared. And in particular, if you FOIL this out, you'll get this. Same with this one. And then I'm going to add all this up. I'm going to get, I haven't done it yet, so let me do it real quick. It's kind of easy. You don't even really need a calculator. It's just going to be 6,400. And then you just divide everything, you put in standard form by 6,400. And this is just going to be x minus 1 squared over 100 plus y plus 1 squared over 64 equals 1. And that's your answer. The way they do it on their, they just bring out this, so that they're going to write it as 1 over 100 times x minus 1 squared plus 1 over 64 over y plus 1 squared equals 1. Equals, these are the same thing. So basically just know how to complete the square and know what the equation of ellipse and hyperbola and all that is. So the next one is the same thing. We have a parabola. Parabolas are more awkward. And I'm going to, if you're really good at completing the square, you're not going to have to do what I'm doing. What I'm going to do is I'm going to move the 14 over. So subtract it. Then I'm just going to deal with this piece. I'm going to factor out a 4 and get x squared minus 2x. Go ahead, and I would like to put my little box or square. When I complete the square, I'm going to put 1. So we have to add that on this side, 4. Remember, you have to add we're adding 1, but we're really adding 4 times 1, so it's 4 times 1. All right, and simplify the left, you get minus 10 equals 4 times x minus, you just take half of that, 1 squared. Remember, we just made a perfect square trinomial. Then I add the 10 back to the other side. Like I said, if you're really good at this, you didn't have to move the 14 over. You could have done it on that side. And so that's basically that. Okay, the next one is an identity. No, it's not an identity. They just want you to simplify this. So that's what we're going to do. And usually when you simplify, you want to write everything in terms of sine and cosine. So that's what I'm going to do. This is 1 over cosine of theta minus sine over theta over cosine of theta times sine of theta over 1 plus, now sine of 2 theta is 2 sine of theta cosine of theta. That's your double angle identity over 2 sine of theta. Now you simplify it and these two go away, and I'm going to take care of this. So I get my common denominator. This is right here. This is going to be 1 minus sine squared over cosine of theta plus cosine of theta. So 1 minus cosine squared is cosine squared of theta, oops, put your theta, over cosine of theta plus cosine of theta. So this goes into that 1 time, so you get cosine of theta plus cosine of theta equals 2 cosine of theta. Alright? And so it's just nice because this one wasn't really that hard. Just break it down and simplify as much as you can. Alright? The next one looks really scary to me. Basically what I did is I used the sum and difference formulas for this. So I'm treating this as my alpha and my beta. Alpha and my beta. And I'm using, don't forget your sum and difference formula, cosine of alpha minus beta equals cosine of alpha, cosine times cosine of beta, plus sine of alpha, sine of beta. And sine of alpha minus beta equals sine of alpha, cosine of beta, minus cosine of alpha, sine of beta. Now what's problematic about this is really this k part. You don't really need the k to solve this, because the k just represents any integer. That means we have the same value if k was 1, 2, or 3, because it's the period of sine and cosine is 300 or 2 pi. So we can just, I didn't even deal with that. I just crossed those out. So my alpha is going to be 2 pi on both of these. So when I simplify this, I'm going to try to write small. I'm going to get cosine, I'm using this now, cosine of 2 pi, cosine of theta, plus sine of 2 pi, sine of theta. Alright? Let me see if I can squeeze this in. And then we get sine of 2 pi, cosine of theta, minus, I'm not going to be able to do it, cosine of 2 pi, sine of theta. So let me take care of this. Cosine of 2 pi is 1. And sine of 2 pi is 0. So that knocks that out. So we just get 1 times cosine of theta. This is just going to be cosine of theta. Alright, and don't forget this negative. What I'm going to do is I'm going to take this negative out and put it in front of this whole thing. So I still have this negative out here. Alright, so that's this. Cosine of 2 pi is 0, so that's 0 times that. That just knocks that out. And cosine of 2 pi is 1, so you get times negative 1 sine of theta. two negatives here make a positive, so you're just going to get cosine of theta, sine of theta. And that's your answer. So this was pretty easy if you kind of didn't let this k part bother you. Alright, that's all of this one, and the next ones we'll start with 21, and you're basically halfway there. Bye, and have a nice day.